All right. Part A, find the position of the particle at t equals 3. So to find position, we need to just use x of t and y of t. Well, they give us dx dt, and then they also give us y of t, right? So in order to find our position, all we need to do is first off to find the x coordinate, integrate our dx dt. So if we integrate the dx dt, we'll say the integral of dx dt from, we're talking about 0 to 3. What do we need to add to that to find the x coordinate? We need to add to it the initial x coordinate, which is 5. So 5 plus the integral from 0 to 3 of dx dt. What did that come out to be? 19, let's see. No, I disagree.
Yep, 14.377.
14.377.
Yeah.
That's not what you, is that what you did though, Noah? And you got a different number? Make sure your calculator is in radians, not degrees. Maybe? Yeah. I don't know. Then I don't know what you did.
I got just 9.377 for the integral, and then just 5 more than that.
Yeah, the 5, yeah. What's the matter, Noah? Please don't find the integral. Yeah. Please use your calculator to evaluate that definite integral. You did not find the integral correctly because you did not find the integral of sine of 3t squared. Guaranteed. So, did you guys get that value? Yeah, yeah. But now you know how to do it. Yeah. Everybody else at home, good? Any questions? Okay. See, failing on this one is good because then you learn the next one. Then you don't fail on the next one. Then you don't fail on the AP test. All right. What's y of 3? Negative what? Oh yeah. I thought you said negative 0. I'm very confused. Negative 1/2, right? That's just the y value. That should be easy enough for the y value. They gave you 3 points. 1 point for the integral, 1 point for using the initial condition, and 1 point for the final coordinates. Good or no? Any questions on part A? Everyone's good? All right, part B, find the slope of the line tangent to the path of the particle at t equals 3. So the slope of the line tangent to the path should just be the derivative, right? dy dx. And we know that dy dx ought to be dy dt over dx dt. And we're looking for this all at t equals, what did I say, t equals 3? Yeah. So dy dt, that should be the slope of this at 3. What's the slope of this at 3? 1/2. And what's the slope of x? Well, that's the derivative. Actually, it's just this thing evaluated at 3, which should be 9 plus the sine of 27. And you've got a calculator, and your calculator will tell you what 1/2 divided by 9 plus the sine of 27 is. And it will tell you that it is 0.05. Must have been 0.050. I'm going to put the 0. Everybody good with that? Part B, pretty easy. Part C, find the speed. So we need to remember that speed is the absolute value of velocity, right? That's always true. Right? Speed is the absolute value of velocity. So it's the absolute value of the velocity vector, right? So since we're talking about a vector here, the absolute value of the velocity vector ought to be dx dt, dy dt, right? That's what we're looking for. Well, how do you find the absolute value of a vector? Pythagorean theorem, exactly. It's just the magnitude of that vector. So this ought to be the square root of dx dt squared plus dy dt squared, evaluated at t equals, I don't know what it is, t equals 3. All right. And your calculator will tell you what that is. You don't need to actually like do anything other than write this out. And what do you get? 9.969. Everybody good with that? Yeah. Everybody at home on the Zoom good?
Good Zoom.
Good Zoom. Nobody has any questions at home? You all are good? That was worth 2 points. One for an expression for the speed, whether it be this or this, right? They probably wanted to do this one, and then one for the answer. All right, part D says the total distance traveled. Well, remember that to find a total distance, not a displacement, but a total distance, we have to integrate the speed. That'd be cool. Like that. There we go. The integral of speed equals total distance. So all we need to do is we need to integrate, what was it, from 0 to 2? Our speed equation, dx dt squared plus dy dt squared, all square rooted. And we integrate. And what do we get? We didn't get this one. Okay, so we have to, what do we need to do with this? We have to do something with this because of this. Right, from 0 to 1, dy dt is and from 1 to 2, dy dt is 0. So since dy dt changes on that interval, it's not just a singular function, we've got to go in. I shouldn't write it approximately. We should write is equal to the integral from 0 to 1 of dx dt squared plus 2 squared. Or sorry, it's negative 2 squared, right? All inside just square root. Plus the integral from 1 to 2 of your dx dt squared plus 0 squared. And once you've done that, you should be able to get your answer. Looks like it comes out to be 4.350. Any questions on that? People at home good? People here good? At home, are you good?
Good Zoom.
Good Zoom. Okay, 3 points for that one. One is this. Well, one is this. Actually, I don't know. I don't like how they've written out their scoring guidelines here. Doesn't make a lot of sense. I would say 1 for this, 1 for splitting it into 2, and 1 for the answer. I think is what they're trying to say from their scoring guidelines. Everybody good there? Should we do another one? Let's do another one. Another one sounds good. Here's another calculator one. Ready? Everyone was good with the last one? This is the next one in the packet. Yeah. All right, ready, go. She also didn't actually say that. I just lied and said that she said that. All right, so A, find the x coordinate of the position of the particle at t equals 2. So to find the x coordinate we just need to integrate the x-coordinate of the velocity and then add the initial position. Right? So the initial position was 3 for the x-coordinate plus the integral from 1 to 2, because our initial condition is at t equals 1, and we're looking for at t equals 2 of cosine t squared dt. And that came out to be what? 2.557. Everybody agree with that? And that was worth 3 points, amazingly. 1 for the integral, 1 for remembering the initial condition, and 1 for the value. All right, part B. Any questions on part A before we do part B? Everyone good with A? Yeah. Okay. Part B. For 0 to 1, there is a point on the curve at which the line tangent has a slope of 2. So we just need to set dy dx equal to 2. And so what's dy dx? It's dy dt over dx dt. And dy dt is e to the 0.5t. And dx dt is cosine t squared. So just set that equal to 2. And graph this equation on the left, graph y equals 2, see where they intersect. Or graph this equation on the left, minus 2, and find the x-intercept. So it looks like there is a point between 0 and 1. Looks like that point is 0.840. Is that what you guys got? Or no? Yeah? No, yeah? Derek? Good? You've got it wrong. Uh-oh. Does it make sense now? Jenna, you're good with that? What? Now you are. Okay. People at home, are you good with that or no?
Yep.
1 point for this, 1 point for this. All right. Part C. We want to know the time at which the speed is 3. So speed being absolute value of velocity means take the velocity vector and find its magnitude. So what we say is time when the speed is 3. So 3 equals the square root of, what was the first piece of that? It was cosine t squared. So cosine squared t squared. And then the other piece was e to the 1/2 t. So just e to the t. And solve that equation. And that ought to give you the t value, which looks like it comes out to be 2.196. Everybody good with that? They gave you 2 points for that, 1 for having the speed and 1 for the answer. Any questions on that part? So the one for having like the speed equation, not the whole equation, just the representation of speed, and then 1 point for the answer, the time. All right. Any questions on C? No? All right, and then D, find the total distance traveled from 0 to 1. So that's the integral from 0 to 1 of this speed equation, cosine squared t squared plus e to the t dt. And that came out to be 1.595. And they gave you 1 point for the integral setup and 1 point for the answer. Hopefully that one wasn't too terrible. Not too terrible. Good. Let's do one more, and then I'm going to assign you a couple more to do that we'll go over first thing tomorrow, and then that ought to be good for motion problems, I think. Probably. Yeah. We'll see if we need more by the end of the week. But let's do this one. This is the third one in that packet. Probably from 2014, though, if you're asking, which I bet you will be. You'll note that these are all fairly similar, right? So once we've done 6 of them, you've pretty much seen all the different little components that they might throw. Yeah, there's always little twists, like they might give you a graph and little things like that, but they're generally asking similar things. right, 15 minutes. Ready to go. Part A is the horizontal movement of the particle to the left or the right at time t equals 2. So what will determine if it's moving left or right? Dx dt. So we want to know for A is dx dt at t equals 2 positive or negative, right? So dx dt at 2, well, it looks like dx dt actually is always going to be positive for any t value that we put in. We're going to say that's greater than 0. So to the right. And then your explanation would say, well, dx dt is the velocity of the particle in the x direction, so it's positive, so it's to the right. Find the slope of the path of the particle at t equals 2. So we are looking for dy dx, which is dy dt, so sine squared of 2. Sine squared of 2 over, what is that, square root of 4 over e to the 2. And what did that come out to be? 3.055. People agree with that? Everybody good with part A? All right. Part B. We want to find the x-coordinate of the particle's position at t equals 4. So we're given a position at 2, so we're going to integrate from 2 to 4 to find the displacement from 2 to 4. And it was just of the x part, right? That's all it asked for? Yeah. So then we need to add our initial condition of 1. So 1 plus this x. And what did that come out to be? 1.253. That you said? Jenna, yeah, agreed. Derek? Oh, you had your limits wrong. People at home good with that?
Good.
All right. Excellent. Part C. We're getting better at these particle motion ones, yeah? Well, that's a good question because I couldn't get the scoring guidelines to pull up on my phone because for some reason the service died on it. So I'm not sure. I'll try and do it again in a second once we get through the rest of it. Part C, find the speed at t equals 4. So once again, speed is just dx dt squared plus dy dt squared evaluated inside of a square root at, what was it, t equals 4? Yeah. And what did that come out to be? Everybody agree with that? 0.575? We agree with 0.575 or no?
Yep.
Yeah? Jenna, you agree with that? Derek, what did you get? How many of you at home got 0.575?
I got 0.575.
That's one person. Did lots of you, what did you get, Jenna? 0.7 something? Or 1 point something. Maybe. What did I tell you the last year was? Was it 2015? Yeah. So this one's probably 2014. Let me see if I can get this to pull up now. It doesn't look like this is still working. Yeah. I don't understand. Like I have service, but my phone doesn't work half the time in the classroom. Are we good with 0.575 or no? Whoever left. I'm pretty sure that's all right. Let's go with 0.575. Jenna, you got that this time? No? Okay. All right. We're going to stick with 0.575. Then we want to find the acceleration vector at 4. So we got to take the derivative of each of those bell rings. So we'll do the rest of this last time. We'll do the second part of C and D next time. Tomorrow, let's see, that was problems 1, 2, and 3 from that packet, is that right? Yeah. Tomorrow, I would like to have you guys already have gone through 4, 5, and 6. And then we'll probably call it good on the motion problems unless people have specific questions on the rest. So pages 4, 5, and 6 for tomorrow. Everybody good with that? 4, 5, and 6 for tomorrow. People at home, you're good with that? 4, 5, and 6?
Yeah.
Going over 3, go over 4, 5, and 6 real quick, and then we'll start taking a look at some other types of FRQs.